A galaxy so massive, so ancient, and so unexpected that astronomers are now asking one terrifying question. What if our understanding of the early universe is incomplete? The James Webb Space Telescope has discovered a mysterious galaxy from the dawn of time, a galaxy so large and developed that, according to what scientists thought they knew, it almost should not be there. Some are calling it a red monster, not because it is dangerous, not because it is alive, but because it appears enormous, ancient, and deeply red in Webb's infrared view, a glowing cosmic giant hiding in the early universe. And the shocking part is this. This galaxy seems to have formed when the universe was still extremely young. At that time, galaxies were expected to be small, messy, and still under construction. But this one looks different. It appears massive, it appears evolved, and it may force astronomers to rethink how quickly galaxies could grow after the Big Bang. To understand why this discovery matters, we need to travel back nearly 13 billion years. Imagine the universe just after the Big Bang. There were no planets, no stars, no galaxies, no Earth, no Sun, no Milky Way. Just an incredibly hot, dense, expanding universe filled with particles, radiation, and darkness. As the universe expanded, it cooled. Tiny fluctuations in matter began to grow under gravity. Over millions of years, gas collected into larger and larger regions. Eventually, the first stars were born. These first stars lit up the darkness and began the long process of building the cosmic structures we see today. Galaxies formed slowly, pulling in gas, creating stars, merging with other galaxies, and growing over time. That was the standard picture, a gradual cosmic story. Small galaxies first, then larger galaxies, then giant galaxies much later. But the James Webb Space Telescope is now revealing something strange. The early universe may not have been as slow as we thought. Webb can see farther into space than any telescope before it. And because light takes time to travel, looking far away means looking back in time. When Webb observes an extremely distant galaxy, it is not seeing that galaxy as it is today. It is seeing that galaxy as it existed billions of years ago. That means Webb is not just a telescope, it is a time machine. And this time machine has found galaxies that look too massive, too mature, and too bright for their age. The Red Monster Galaxy is one of the most fascinating examples. Its red color is not simply because the galaxy is actually painted red. In astronomy, extremely distant galaxies often appear red because the expansion of the universe stretches their light. Light that once left the galaxy as ultraviolet or visible light gets stretched into infrared wavelengths by the time it reaches us. This is called redshift. And the greater the redshift, the farther back in time we are looking. So when Webb detects a very red galaxy, it may be seeing an object from the earliest chapters of cosmic history. But here is where the mystery becomes serious. If this galaxy is truly as massive as observations suggest, then it must have formed stars at an incredible rate. It would have needed to gather gas, compress it, ignite stars, and build up a huge amount of stellar mass in a surprisingly short amount of time. That creates a problem. Because in the standard model of galaxy formation, massive galaxies require time. They grow through repeated star formation and mergers. They collect matter from their surroundings. They evolve over hundreds of millions and billions of years. But this object appears to have done something much faster. It is like finding a fully built skyscraper in a city that was supposedly only beginning to lay its foundation. And that is why astronomers are paying close attention. This discovery does not automatically destroy the Big Bang model. It does not mean everything scientists know is wrong. But it does mean there may be missing details in the story. The early universe may have been more efficient at forming massive galaxies than previously believed. There are several possible explanations. The first possibility is that early galaxies formed stars much faster than expected. In the young universe, gas was more abundant. Galaxies may have been packed with dense clouds of hydrogen and helium. If those clouds collapsed efficiently, they could have produced enormous bursts of star formation. Instead of slow growth, some galaxies may have gone through extreme star-making events. In that case, a young galaxy could become massive very quickly. The second possibility involves dark matter. Dark matter is invisible. It does not emit light, it does not reflect light, but it has gravity. And scientists believe dark matter forms the hidden skeleton of the universe. Galaxies are thought to form inside dark matter halos, invisible gravitational structures that pull in gas and help stars form. If massive dark matter halos existed earlier than expected, they could have helped build large galaxies sooner. This would mean that the cosmic web, the large-scale structure of the universe, became organized more quickly than models predicted. The third possibility is that some of these early galaxies may not be as massive as they first appear. This is important. Astronomy is difficult. When scientists look at an object billions of light years away, they must estimate its distance, mass, age, and star formation rate from faint light. Sometimes, dust can make galaxies appear redder. Sometimes, active black holes can make galaxies appear brighter. Sometimes, measurements change when more data arrives, so scientists are careful. They do not jump to conclusions from one image. They use spectroscopy, infrared measurements, models, and follow-up observations to test what these objects really are. But even with that caution, Webb has found enough surprising early galaxies that the mystery is growing stronger. This is not just one weird object, it is part of a larger pattern. Since JWST began observing the deep universe, astronomers have found multiple galaxies that seem unusually massive for their time. Some may contain more stars than expected. Some may have formed earlier than models predicted. Some may be more chemically evolved than they should be. That means they already went through generations of star birth and death, and that is extraordinary, because heavy elements are not born in the Big Bang in large amounts. Elements like carbon, oxygen, silicon, and iron are forged inside stars and spread into space when stars die. So if an early galaxy already contained signs of chemical maturity, it means stars had already lived, exploded, and enriched the galaxy before we are seeing it. That pushes cosmic development earlier and earlier. And every time Webb looks deeper, the early universe seems more active, more complex, and more surprising. This is one reason JWST is such a revolutionary telescope. Before Webb, the Hubble Space Telescope gave us incredible views of distant galaxies. Hubble changed astronomy forever. But Webb was designed to see the infrared universe. That matters because the most distant galaxies are shifted into infrared light. Webb's giant mirror and advanced instruments allow it to detect faint objects from the cosmic dawn. It can study galaxies that existed when the universe was only a fraction of its current age. And now, Webb is showing scientists that the first galaxies may have grown faster than anyone expected. This discovery raises a huge question. Did galaxies form earlier than we thought? Or do we need better models for how matter behaved in the young universe? The answer may change our understanding of cosmic history, but science does not move forward by protecting old ideas. Science moves forward when evidence forces us to ask better questions. And that is what this galaxy is doing. It is challenging the timeline. It is challenging assumptions. It is telling astronomers that the early universe may have been more intense than expected, more crowded, more energetic, more efficient at building structure. Now imagine what this means. If massive galaxies existed so early, then star formation may have begun earlier. If star formation began earlier, then black holes may have grown earlier too. If black holes grew earlier, then the centers of galaxies may have become active sooner. And if all of that happened earlier, then the entire timeline of cosmic evolution becomes more complicated. This is why one galaxy can matter so much. A single discovery can act like a crack in the wall. At first, it looks small. Then more cracks appear, and eventually, scientists realize the wall needs to be rebuilt. That does not mean the old science was useless. It means the old model was incomplete. That is how science works. Newton's laws were not useless when Einstein came along. They were still powerful. But Einstein revealed a deeper layer of reality. In the same way, current galaxy formation models may still be useful. But JWST may be revealing a deeper layer of cosmic history. A universe that built galaxies faster than expected. A universe where massive structures emerged during the first chapters of time. A universe that was not quiet and slow, but violent, efficient, and full of surprises. And the most exciting part is this: JWST is only beginning. The telescope is still collecting data. Astronomers are still analyzing deep field images. New discoveries are still being confirmed. And future observations may reveal whether this red monster is truly as massive as it appears, or whether something else is making it look that way. Either outcome is exciting. If the galaxy really is that massive, it forces scientists to revise their models. If it is not, then scientists learn more about how dust, black holes, and early stars affect what we see. In both cases, the universe wins. Because every answer leads to a deeper question, and that is the beauty of astronomy. We are tiny creatures on one small planet, looking into the darkness with machines made of mirrors, sensors, math, and imagination. And somehow, we are able to see light that has traveled for billions of years. Light that began its journey before Earth existed, before the sun existed, before our galaxy looked the way it does today. That ancient light has crossed the expanding universe just to reach our telescopes. And inside that light is a message. The universe was more mysterious than we thought. The early cosmos was more powerful than we imagined. And somewhere near the beginning of time, massive galaxies were already lighting up the darkness. So the next time you look at a deep space image from the James Webb Space Telescope, remember this. You are not just looking at stars. You are looking at history. You are looking at the fossil record of the universe. And sometimes, hidden in that ancient light, scientists find something that should not exist, at least not according to what we thought we knew. A red monster, a cosmic giant, a galaxy from the dawn of time that may rewrite part of the story of how everything began. And maybe that is the real lesson. The universe does not care about our expectations. It does not follow our theories just because we want it to. It reveals itself slowly, one discovery at a time. And with JWST, we are finally seeing parts of that story that were invisible before. The deeper we look, the stranger the universe becomes. And the stranger it becomes, the closer we get to the truth. This is Infinite Science. Thank you for watching. If you enjoyed this journey into the early universe, make sure to like, subscribe, and stay with us for more discoveries that challenge what we think we know. Because the universe is not finished surprising us.